Let's take a look at how we solve for the number of periods. So suppose you have a certain amount of money in the bank, a certain present value, and you'd like to know how long is it going to take to grow to some future amount, given the interest rate you're earning. So how do we do that? We have the basic future value equation for a lump sum. Future value equals the present value times 1 plus the interest rate raised to the tth power. T is the number of periods, R is the interest rate. So if we know the present value, the future value, and the interest rate, we can solve for T. So the first thing we do is we divide both sides by the present value, and we get FV over PV equals 1 plus R to the tth power. Now we've got to get T out of the exponent, and it turns out that if we take the natural log of both sides, it will do that. It will do that because the rule of logs is that the log of 1 plus R to the tth power is the T drops down here and it becomes T times the natural log of 1 plus R. So taking this, and of course we took the natural log of this side. Whatever we do to this side, we have to do to this side. Now we divide both sides by the natural log of 1 plus R, and we get T equals the natural log of the future value over the present value divided by the natural log of 1 plus the interest rate. Let's take a look at an example. Suppose you put $100 in the bank at an interest rate of 6%. How long will it take for the money to grow to $150? Well, following that formula, the future value is 150, the present value is 100, so it's 150 over 100. We take the natural log of that, and then we divide it by the natural log of 1 plus the interest rate, in this case 6%. We have to put it in decimal form, 0.06, and if we do that, we get 6.96 years. Using a financial calculator is actually quite a bit easier. So here I have my financial calculator. I'm going to clear the workspace. So you hit second, and over the FV key it says CLR TVM, time value of money, and I'm going to put in the values. The $100 for the present value has to be negative because it's a cash outflow. 150 is the future value, 6% is the interest rate, and then we hit compute CPT N, and we get the same thing, 6.96. You can also do this if you have annuities. Now, you can probably derive an equation for this. I was trying to do it, but it gets kind of messy. You should actually want to do this on a financial calculator. So suppose you save $100 per year starting next year. How long will it take you to reach $1,000 if the interest rate is 6%? So what do? We put into the calculator the interest rate is 6%, the payment is 100 minus 100, and the future value is 1,000, and we hit compute N. So let's try that for this example. So the interest rate is 6%. You put it in as a whole number. PMT is minus 100, and the future value is 1,000, and you hit compute N, and you get 8.066 or 8.07. So you can see that it doesn't actually take you 10 years to accumulate the $1,000. It takes you a couple of less years because you're earning interest on the money you receive. Let's see how you do this in Excel. So easy enough to do in Excel. So here I have the information that's given. In Excel, the interest rate is called rate, not R, and N is NPER, number of periods, and we put it in this way. We're going to use the N period function, And you can't see it very well, but it tells you what to put next. It says rate, and then I'm going to put a comma. It asks for PMT. In this example, I don't have a PMT, so I'm going to put 0 in. It asks for the present value now, comma, and then the future value, and I'm going to close the parenthesis, and I get the 6.958 or 6.96. Over here, the second example where I did it with an annuity, same thing, end period, the rate is 6%, the payment is minus 100. In this case, we don't have a PV, so I'll just put 0 in, and the future value was 1,000, and again, I get 8.066. So I get the same answers, and I can do it in Excel, or I can do it on the financial calculator. I really would recommend that you use either Excel or financial calculator. There's no reason to fool around with the natural log formula to get this to work. So I hope you found this useful, and thanks for watching.